We are on the grade 8, module 4, lesson 13, which starts out on page 56. So, lesson 13, the graph of a linear equation in two variables. So, we kind of talked about the phrase linear equation before. I'm going to just remind you, a linear equation is when you have two variables with no exponents other than an invisible one. So, but they're not going to make the one visible. So, we'll leave that as is. Going on from there, let's get into exercise 1. So it says, find at least 10 solutions to the linear equation 3x plus y equals -8 and plot the points on a coordinate plane. We have our coordinate plane on a separate sheet of paper. Let's get into our table where we'll pick our 10 points. So you remember from last video, kind of the same deal. They gave us an equation. It had two variables in it. I showed you a little trick though on how to make your life a little easier. You want to pick variables. You want to look at the equation and you want to figure out which variable is in the more complicated term, meaning that we have 3x, here we have just y. We're going to pick variables for the x. That way, it makes our life a lot easier to figure out what y is, and then we'll have our total coordinate point. So for our x values, let's pick these numbers. And again, you can pick any numbers you like. It doesn't have to be the ones that I use, but for the sake of doing this exercise, pick the ones I use. When you're doing it on your own, though, you may select any x values. Some of them will be better to pick than others, but mathematically it'll all work out. So there we go. I picked -6 all the way up to +3. So in our linear equation, here is what is going to happen. We're going to keep the 3. Instead of the x, we're going to put in -6 in parentheses. Plus, then we'll have our y equals -8. So let's figure out what happens when x is -6. Well, 3 times -6 gives us -18. So we have to figure out what number y has to be so that -18 plus that number equals -8. Well, the way you could figure this out is you could you could add 18 to both sides, or you could subtract -18 from both sides. I'll show you the little bit of work up here. So we could do -18 plus y equals -8. We could add, because that'll cancel out with -18 equals 0. And we'll have y equals 10. So when x is -6, y equals 10. So if you're having a tough time remembering your addition facts of negative numbers, you could just do it the algebraic way like that. I am going to kind of just substitute in and use our our addition facts from here on out. Next one down, I'll have 5 parentheses, no, I'm sorry, 3 parentheses, -5 plus y equals -8. I know that 3 times -5 gives me -15 plus y equals -8. I think, okay, what do I have to add to -15 to get it to -8? That's going to be +7. Good way to check, if you type in 3 times -5 plus 7, you will get -8. So when x is -5, y is 7. And we keep going. So again, substitute in 3 times -4. Put in the rest of the equation, plus y equals -8. 3 times -4 is -12. -12 plus y has to equal -8. So that tells me that y has to be +4 equals -8. So y will be 4. All right. So go ahead, fill in the rest of this table, then we'll double check, and then we will enter in, or go ahead, plot in all of our graphs. Okay, there we have the rest of our coordinate points that work. We're going to go ahead, we're going to plot as many as we can on our first graph right here. So going over to our first graph, let's go ahead, let's label it exercise 1 so we can get back to it pretty quick. So we'll just put up exercise 1. There we go. And let's start plotting points. So I'll zoom out a little bit. I'll plot the first couple, then just re-explain how to do it. Then I will let you carry on. So first one, remember we do the x value first, then the y value. So x, then y. So we have -6, 10. So let's see, -6 means, so you always start at the origin. Then you go, first number tells you which way to go, left or right. So -6 tells us to go to the left. Uh-oh, almost forgot something also. We got to label, we got to make sure we tell what our graph is going by. So I'll put a 10 there, -10 down here because there's 10 grid lines in between. So that just tells us we're counting by ones. Same over here, get it perfect on that line, -10, +10. There we go. All right, so start at the center. We'll go over 6. 1, 2, 3, 4, 5, 6. Oh, don't put a point there though. And up 10. And I know that's all the way to the top. Do the next one, which is -5, 7. So almost all the way over to where we were. Up 7. There we go. Same deal, we'll keep going. -4, 4. So 4 to the left. 1, 2, 3, 4. Up 4. All right, now we're going to keep going. Well, I'll have you keep going. I'll let you continue to plot these points. So then we'll double check, make sure we got the same thing. So there we have it, plotted all my points. All right. Now, the question at the bottom, back in our module book, what shape is the graph of the linear equation taking? Well, you can look at these points right here, and you can tell that they're all lined up. And that kind of makes sense because if you think about the word linear equation, where all these points came from, the first 4 letters are line. Well, that's why it's called a linear equation. We see how all of them are lined up. Let's use a ruler and make it even more clear. So I used a ruler, I lined up the first point and the last point. First point, last point on my graph. I notice how all of my points are touching on the lines, or at least on the line or touching the line. They're all on the line. It's just when I'm not using when I'm doing it by hand, even though I am on a computer, the points won't perfectly touch. If I had a computer program that I was doing this with, like Excel, they all would perfectly touch. Long story short, every point that is a solution point is going to be on this line. So back to our question, what they were asking us. What shape is the graph of the linear equation taking? We'll just say a line.